Alrighty, welcome to Financial Algebra. Today what we're going to be working with is we're going to be working on exponential depreciation functions. And what I want you to do is I want you to look at the poll and decide, you can mark more than one, so mark the true statements, 1, 2, or 3. Ready, set, go. I'm going to give you like 30 seconds. Okay, I think I gave you enough time. And like I say, you can pick more than one answer, and we will go over these answers. And I know the expressions are a little hard to read just because they're all just one line versus subscripts and superscripts. Good job, Taylor. And Sativa, if you want to, you could take over one too. Or not, that's fine as well. So let's talk about what I want to do is I want to intro for this discussion. First of all, let's look at the objectives. Today in our webinar, we will understand how to write and understand exponential depreciation functions. And then success criteria is we're going to write exponential depreciation function and then find the depreciated value of a vehicle after n years. Just a reminder, next week, Thursday and Friday, are no school days, but you can still work on your work. That's really cool. I love that. So let's look at this discussion. I'm going to make it a little bit more obvious that that's what we're working on. So discussion. I'm going to give you, I'll read it. Do you think that automobiles lose value at the same rate each year? And defend your answer. Okay, so I'm going to give you a minute to answer that and see where we get after a minute. If you need two, then I'll go ahead and give you 2 minutes. So do you think that automobiles lose value at the same rate each year? And defend your answer. I'm liking your answers. Good job. Okay. Does anybody want to activate their mic and share in voice what you put? And if not, it's okay. I'll go over it in voice for you. Does anybody want to comment on anybody else's comment? Like, did you note something about their comment? And if so, you could use the chat box and identify the name and give a comment or give a question. Okay. Okay. So Sativa brings up a good point. She says no, if the model is not being made anymore, then the person who owns a car or the dealership, they can increase the rates, right? They can move it up. And so I think that affects, I would agree that that would affect the value, whether they depreciate the same all the time. And then Monte says they don't lose the same value per year because a large portion of value is lost once the car is driven away from the dealership. Okay, Monte, do you have like an example of that? Have you experienced, like, I guess, have you experienced that with something that you've bought? So it's just because math teachers rule and you listen to them? Okay. You know what, my challenge to you, if you choose to accept, is to go see if you can find book values of a car that's brand new. And I think the car places have their brand new sites. And then see if you can find a car that has like 500 miles or less and see how much it's come down. I'm going to also research that and maybe put an interesting FYI fact out there. Okay, and then Taylor, I like how you brought up that if the owner takes good care of it, it doesn't lose value as quickly as if the owner crashes into a lake. That would lose value quicker. I agree with that. Also, the other thing that I was thinking of is sometimes do cars, last week we spent time on doing what's called straight line depreciation. And this week we're going to do what's called exponential depreciation, and some of you have done that. So do they always lose value at the same rate? So like if you bought a $20,000 car, does year one, do they lose 2,000, then 2,000, then 2,000, then 2,000? Or is Monte got something going on where he says, no, as soon as you drive it off, it's losing something? Or does it say $20,000 car lose 2,000 the first year and 15 the second year and 14 the next year, and you know how it's kind of decreasing at an exponential rate versus a straight line. So we're going to go into that, and we're going to now answer the poll, show you how to work the poll for those things. You ready? You ready? Okay, so I totally have to find this student who just totally got lost and stick you over there. Nice, I think I got it. Monte totally just deleted what he had to say. That's okay. Okay, so let's look at our webinar. So true or false, and don't delete it. Well, I don't, whatever. True or false? You know what I'm going to do real quick? I'm going to have you guys don't delete anything. Don't delete anything. Find out where things went. I like your answers, so I don't want them to go away. Okay, maybe I have to find them. Oh, there it is. Monte, did you take over another one? No, you deleted yours. Okay. So what I'm going to do is I'm going to have Sativa and Taylor take over two other pods. Okay. Take over the two that Monte's got his name in there. Take over the other two because I want to save what you guys wrote. I might use it for the discussion for the webinar. Anyway, so let's look at one. I should have numbered those. So let's look at 1, 2, and 3, and let's give them some numbers. Let's change colors here. It's a good color though. So 1, is it true or false? 2, true or false? Oh, that's not even working. There we go. I think I got it. I have to get used to being able to write on this board and put my hand down. So I'm used to writing on an iPad, and the iPad, if you do that. Okay, so true, true, false, false, or false, false, true, true, or true, false, true, or false, true, true, or false. There's 9 options, by the way. Six options. So I'm going to remind us of our PEMDAS rule. And so the biggest one that we have right here is exponents. So what that means is I need to process this sucker first. So that's 2 squared, or 2 to the x power. And this is saying 10 to the x power. So this one is actually false. That one's false. Okay. If this were to be true, I'd have to have 5x and 2x. That would equal 10x. Okay, what about this one? True or false? You picked true, true. Everybody picked true. Nice job, guys. It is true. Because I can write this as 5, oh, screwed up. 5 squared parentheses to the x power. And so you can see how that is 25 to the x power. So nice job, guys. So this one is true. Kind of reminding where our exponents go, because in this section, it's important to make sure our parentheses and our exponents go well. What about 3? True, true, false. This one is actually a lot like this rule. So this one actually is true. This one's true. Because when I have a power to a power, we're just going to multiply that. So this one here is 5x times 2, which can be written as 5 2x. Cool, huh? I know, it's super cool. So let's go look at this. What we're going to get into is depreciation, exponential. Here's our formula that you use. And we got green for the original amount. That's going to be the amount of when you get the car. Often we're going to call it, you know, the new car price. But what if you just bought a car that was, say, $8,000? Then you can use that for that as well. But often in our stories that we work on in this section, most of the things we give you is a new price. Okay, depreciation rate, just a reminder, it must be a decimal, okay? Must be a decimal. If it's not, then your numbers come out wrong. And then T will be time in years. So if we're talking about a half a year, then T would be 0.5. Okay, you ready? So let's look at our story problem. Shannon's new car sold for $28,000. Her online research indicates that her car will depreciate exponentially at the rate of 5.525 per year. Write the exponential depreciation formula for Shannon's car. Okay, so what do you guys think? If I have, what do I have? Y. Remember, y equals a, parentheses, 1 minus r to the t power. Let's see what you guys got. And Sativa, good job on getting that decimal correct. Good job. Do you have any questions at this point? Okay. Good. Good. So what is the interest rate? How is this one expressed as a decimal? Nice, you guys all got it. So it's 0.0525. Good job, you guys all got it. Nice. So now we're going to apply, and see all my beautiful colors? You didn't even need them, but there they are. So now we're going to use it for this one and actually crunch some numbers. And so this is the only problem we're going to be working on today. You'll need a calculator once we get to the second part, but let's see if you can get the formula down first. So Chris purchased a used car for $19,700. The car depreciates exponentially by 10% per year. Write the exponential depreciation formula for Chris's car. Nice job, guys. Nice job. So, and I really like that you guys already know that those little caret things work for the exponent. That is something that in your online life has given you benefit because that's not standard knowledge for all students. And it is, if you're typing something in Excel and you need to raise it to a power, that you use the caret to do that. So good. So what I want you to do, we've got the formula, and you guys all did a nice job with that. Oh, hold on. Okay, some of you need to make a correction. Do you see where your correction needs to be? Okay, you got it. You got it. So what you had before was you actually had 1%. And I get why you did that, because sometimes, oh, there's my stuff. Sometimes we do 0.1 for 10%. Sometimes we do just 0.1%. Sometimes we do 0.10. But just remember, all three of those are the same. It needs to follow directly after the decimal. So now what I want you to do is I want you to use a calculator and see what answer you get when in 6 years. And I'm going to see if I can pull up my calculator. What did you guys get? You could just, just crunch it in your calculator. What did you get for your calculator? Let me show you a way, depending on your calculator. Sometimes you might have to put in your calculator this way. First, work 1 plus 0.1. So that's going to be 1.1. Then raise that to the 6th power. And that equals, you don't have to do it this way, because if I had a calculator I did it all in the same step, I would. That equals 1.77. Then we're going to take 19,700 times 1.77. That is a route. And looking to see if Taylor's answer is right. Something. Taylor, what were you using for a calculator? Your setup's right. Well, oh, I know what happened. See your decimal? Your decimal is 1% right now. In the first line, it was 10%. The second line, you have 1. So try that in your calculator. And Monte, you got it. Oh, oh, I know what I did. Okay, guys, total typo. That was a minus. Sorry about that. So this is actually 0.9. I'm glad that Sativa's was doing work for me because then I could see what was going on. So 0.9, and if I do 0.9 to the 6th power, it's 0.53. And then we take 0.53 times 1900. Then our answer should turn out. Okay. Does anybody have any questions on that? Does it kind of make sense? The big thing that I like to do when I'm doing a problem, and it's my strategy, is I like to use colors. Okay, so green, and I go and identify. You know, my formula has an A in it, so I go and I identify that this is A. My formula has an R in it, and so I go through and I identify. There's my R. Go through and identify that that's R. And I might say, you know, that's 0.1. Just kind of to remind myself what's going on with my R. Nice. Okay, guys. So that's what we're covering today. Does anybody have any questions? What I want to look at is let's do it one more time, and let's do it for the first year. What is year 1? And then let's do year 2. So how about if I have you guys all do a different one? Monte, will you tell me what the car's value is in year 1? And Taylor, will you tell me year 2? And Sativa, will you do year 3 for me? And just when you get the answer, just type it, and do me a favor and put year year 1 right before you start typing, or year 2 or year 3, so it's easier for me. I need to selection. Okay. Is it working, Taylor? I told you guys about a really cool calculator, Desmos.com. It's really cool. And you can even download it to your phone. Oh, okay. So what I'm gonna do, Taylor, is, do you want me to show you how to do it on your iPhone? Would that work, Taylor? So if we have 9, 7, 0, 0, and then it's gonna be 0.9, squared, right? So we're first going to focus on that squared part. So what's 0.9 squared? It's going to be, got it, 0.81. Now we're going to take 0.81 times 19,700. Oh, okay, no big deal. And you can, but then your calculator may not calculate it right. But if you have a Desmos app, it will calculate it right. When I'm in the lab next time and I see you, I'm going to get you to do the Desmos app. Okay, so what did your calculator give you when you did that? And Sativa, I just couldn't see your answer. Okay, perfect. Yeah, I just couldn't see your answer. Okay, so 15,957. And then Sativa's answer, that was interesting. I don't know how long you had your answer up there, but I couldn't see it. Okay, great jobs, guys. So we can see that in that first year, it lost close to $2,000. In the second year, it was like $1,800, and in the third year, it was $1,600. So it's changing each year. That change is a little bit different. And when the change isn't the same every year, like 2,000, then it's going to be an exponential function. The function that's up top here is going to be an exponential function. And this one's an exponential decay or depreciation. Usually it's called the decay function for those who want to have the math lingo. But anyway, good job, guys. So go into the, everything's posted, and so you can actually go and complete the webinar assignment right now. Would be a good idea while you're there. And then it just has a question in it that I'd like you to answer. But nice job. So we'll see you later, and as you get questions, let me know. And everybody knows what TTFN means, right?